Today, I would like to give you a lesson on the topic circle, disk, and their elements, part 2. Before starting to watch this video, don't forget to subscribe to my channel and like it. I will be very grateful to you for that. Problem 1.1. All geometric figures shown in the figure lie in the same plane. A circle with center at point O touches 3 sides of rectangle ABCD and has extremal contact with the circle circumscribed around triangle DCK. The radius of the smaller circle is 8. Angle DKC equals A. Determine the catheter DC. So we have problem 1.1. According to the condition of the problem, we have that the radius of the inscribed circle is 8. I mark these 2 radii, and we see that through these 2 radii we can draw a diameter. So this thoughtful smiley wants to tell us that the side that will lie opposite this diameter will be 16. Here I have highlighted this side in red. Therefore, this will be the length of our leg which we were asked about. The answer is 16. Problem 2. Here we are asked to determine, under the same condition of the task, the diameter of the larger circle. Well, according to the previous point, we have that CD equals 16, and the diameter of the larger circle will be the hypotenuse CK. Note that the hypotenuse always lies opposite the right angle. I highlight this right-angled triangle in yellow, and I want us to remember the definition of the sine of an acute angle. If we remember it, we will have that 16 divided by d equals sine of alpha. Hence, the diameter is 16 divided by sine of alpha. Therefore, this found diameter of the larger circle will be our answer. Problem 1.3. In this case, we are asked to determine the distance between the centers of the circles, and so by the condition, the radius of the smaller circle is 8, and the center of the larger circle is the midpoint of the hypotenuse, which we have just determined. So the radius of the larger circle will be d divided by 2. Hence, we find this radius, and we will have that the radius of the larger circle is 8 divided by sine of alpha. We add the radii of the 2 circles. We have, after substitution, that OM equals 8 multiplied by 1 divided by sine of alpha plus 1. That is our answer. Problem 1.4. Here we just need to determine the midline of the trapezoid ABCK, so I have marked the trapezoid in yellow and white. From the previous point, this line that I marked in blue and green will be the midline of the trapezoid ABCK, and we have that the radius of the smaller circle is 8, the radius of the larger 8 divided by sine of alpha. And let's not forget that the diameter is equal to 2 radii of the same circle. So we add the diameter of the smaller circle to the radius of the larger circle, and we will have that the midline of the trapezoid ABCK is 8 multiplied by 2 divided by sine of alpha plus 1. Problem 1.5. Determine the area of the trapezoid ABCK. Well, from the previous points, we have that the midline of the trapezoid will be equal to 8 multiplied by 2 plus 1 divided by sine of alpha. Recall the formula for finding the area of the trapezoid, and instead of the midline, we substitute what we have given, and instead of the height, we substitute the number 16. When we multiply all this, we will have that the area of the trapezoid ABCD is equal to 128 multiplied by 2 plus 1 divided by sine of alpha. Problem 1.6. Determine the perimeter of the trapezoid ABCK. From the previous points, we have that the midline is 8 multiplied by 2 plus 1 divided by sine of alpha. Then we must compose the following equation. And remember that the midline of the trapezoid we can also find by the formula of the half sum of the bases. Now we have this whole equation that I highlighted in white. We must multiply by 2, and we have that BC plus AK equals 16 multiplied by 2 plus 1 divided by sine of alpha. Accordingly, if we know the radius of the smaller circle 8, then the side AB will be 16. I highlighted it in green. Why? Because this side corresponds to the diameter of the smaller circle. Next, I mark the found diameter of the larger circle in red, and we find the perimeter. After calculations, we have that the perimeter of the trapezoid ABCK is 16 multiplied by 3 plus 2 divided by sine of alpha. Problem 1.7. Determine the distance from point M to line AK. So we have that MH is the distance from point M to AK. Note that MH is a perpendicular, because to draw the distance from a point to a line, you need to draw a perpendicular. Therefore, the segment MH will be perpendicular to DK. From the previous points, we have that CD is 16. Now we have that MH, this will be our midline. Why? Because first of all, CM equals MK as radii. DH equals HK. Why? I explain. Because we drop the perpendicular MH to the chord DK, and in this case, this perpendicular will divide the chord into 2 equal segments, DH and HK. So we have that by the property of the midline of a triangle, MH equals CD divided by 2, and is equal to 16 divided by 2 equals 8. Therefore, the answer is 8. So if you understood everything today, I would give you Breguet Grand Complication Marie Antoinette as a gift. If you are worried or excited because you did not understand something, no problem. Watch this video again slowly. Never give up, and I wish you to understand it as soon as possible. Bye!